Welcome to Termite Machine Works. My name is Keith, and today we're going to do a little bit more work on that rudder that you saw us do that freehand cut. Now the customer wants us to go ahead and fair in the leading edge, meaning this is pretty blunt. There is a little sanding going on here, but he wants to take his line is kind of like right around in there, about 1.5 inches, 1.75 inches, almost 2 inches. He wants to fair in the leading edge and the trailing edge. Now I think we're gonna set this up on the accordion trucker. Of course, it looks like a real big machine, but this is a real big rudder. And when we lift this up and get it up there, that mill is gonna shrink down. We're gonna be doing some maneuvering around. I'm gonna be a little creative. How am I gonna hold this up there? And what am I gonna cut it with? I'm looking at this 2-inch shell mill here that was given to me, and I picked up the inserts there. I think I got them on eBay there. They've been working real nice on a few other projects. I have a larger shell mill, 4-incher, but we're only talking about a small cut. And when you have a small cut with only about 5 or 6 inserts on it, which that shell mill does, you have a pounding. It goes boom, 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 boom. And I want it to be more smooth and minimize my amount of area that I'm actually working. So we're going to go ahead and we're going to figure out what angle we're going to set that at. We're going to set this up on the mill. We're going to have to hold down and clamp this down. We're going to have to be creative because that table is only it's only 8 by 48 or something like that, and this rudder here looks like 24 by, I don't know, probably 36 or better. And so we're going to figure out what angle it's going to take to create half of the leading edge or fairing on this side and half on the other side. So let's go ahead, and we want to be able to lift this up and down and move it around pretty easily once we start this job. So I'm going to take the gantry and I'm going to show you how this gantry swings around in my shop. Alright, I start by moving this in around the edge of my lathe before I move that end of the hoist. And we got four casters on here, two at the base of each of the A-frames here. And then this top A-frame pivots. So when I bring it out to here, then I can start swiveling this around in this plane here. Alright, now I go so far, and then I need to start moving the other end into where it's going to, so that they kind of simultaneously swing in this part of the shop here, so that you're bringing it out in the open. You can't just bring this all the way around because we're stiff-legged to the pivot of the other side. So there's where I walk back and forth to compensate and get the thing moved into both positions here. I go ahead and I leave the hoist here in the center section, so that it's not getting caught on any of the machines. Okay, now this normal spot here where I keep it near the mill, it just kind of always gives me the straight across so that I could lift something off of my lathe like the tailstock and set it out of the way to move a long shaft into the steady rest. It usually also pick up something and just put it on the table. But I want to go with the travel of this mill, so that's why we're moving this. So anyway, I bring this in here, and of course I have a mortared floor. There's some little chunks missing and things like that, so I gotta baby it through those holes sometimes. But once I get this out here, and I do pick up my little mat over here, and I just kind of like kick it off to the side there, so it's not interrupting. Alright, so my stove, when in the wintertime, it's real close, but I created this just so that will slip by. And then after that, then I can start pivoting this other end here. And there's another whole section over here that I gotta make it over. And then we go back to the other end again. Alright, we're wanting to bring this leg on over this way here, so I'm going to move my seat that I was sitting on. And pick up my air hose so I'm not rolling over it. And if I'm on that mat, that's going to be okay. That one there, I can, once I get it on there. Alright, now I gotta bring that around there. Now when I get into a little thing here, or whatever, I just like hand pull it over here. Now I have up at the top I have 2 stops on this thing here, and I'll show you that here as soon as I get this over into this area here, right there. Alright, now let's go back to the other end. Alright, I usually hang my slings over this. These 2 studs that I have on both sides, you probably can't see this one over here, but you can see this one sticking up here. This comes around and hits the beam. That is the minimum that I'll let this leg spin, and I put those in there so I wouldn't accidentally line it up and let this thing fall over and crash. It's the last thing you're going to want, right? Now, at times, when I first designed this, and I thought, well, I'm going to be rebuilding this shop, which I don't think I'm going to be doing now, but I thought maybe I would have this on a rolling track or whatever on the floor, or if I wanted to keep it straight in line, I could bring this block against here. And of course, this block here could have been designed with a little bit different material, a little bit more finesse, but this was kind of what I had available at the time. I did offset it so that this could come up close to where that weld is there and have clearance, and this would definitely be positive against here. And then the T-nut just kind of like locks it against the beam, and then that locks this from rotating. So occasionally I do use that, but for the most part it was for a plan down the road. But I leave them kind of loose like this, and these are my anti-fall over stops here, and that's how I did the top. Now a lot of people ask me, you know, what's this section up here? Well, this is 2 pieces of pipe, and I got Schedule 80 pipe. I forget which one. I think the outside was Schedule 80 because I wanted to get the oversized pipe and then bore it so that I was just coming tight tolerances right on there. Hold on. All right, back to this pivot up here. It's 2 pieces of pipe. One is the Schedule 80, and I did a combination of skimming on the outside of the one that protrudes up inside this, and I bored this one here to get a real close fit. I forget what exact sizes of pipe they are in a range, but they are somewhere around the 4-inch diameter up here, 4.5 on the OD probably here. Anyway, it was just a combination that I was able to get that. It is metal to metal with clearance, and this flange and this plate here have smooth faces. Those also were machined. When I assembled this for the only time I ever put this together, it's one time assembling, and I took that old really coarse haired wheel bearing grease, the old school wheel bearing grease. I mean, you put it in there and it looks like spaghetti string, okay? And that grease has held up with a nice pivot on the ends of this, and that's all I've done to this thing since probably, I think I built this a couple months after I got into the building because I needed to start erecting some of this machinery and start moving some stuff around. And so 97, sometime during the year of 97, I built this, and it's been together ever since. It's never been taken apart or never moved. It's always been here. All right, let's finish getting this in a position for our project on the rudder. Okay, I'm swinging this around, but I'm leaving the camera in your position there so you can see how it's able to go ahead and move. All right, now I'm just about in line on this side here. Let's go over to the other side. Just give it a little lift here, and I'll be able to come back this way here a little bit. That looks pretty good. And I kind of eyeball the center run here, and I'm going to put this as parallel as I can with the mill, and then we'll be able to take our dolly. We can put the dolly anywhere underneath here on the floor and be able to pick up the rudder. And we're going to set that level as horizontal as possible. Okay, we're kind of tight here, but we're just at the edge of the hydraulic press has got a leg that sticks out, and I'm right at that with this edge here. I still need to go this way here, I think several inches, and we'll be able to swing that one out there. Now I can pivot this more this way here, and then I can still creep this on over. And I can get it something like that. Now you see that's angling over, but this still got like maybe 3 fingers of hitting the limits there. Alright, and our line of travel now is pretty close to the table. Alright, we're going to go ahead and pick up our part, and then we'll start setting up where the final resting spot for this gantry is going to be to put it in place. We brought the rudder over here. We're going to take our sling and go around the shaft, and then we're just going to pick one point over here on this side, and we want part of the jaw to be down because that's what's going to hold it. Okay. Alright, and then we just tighten it down. I'm just kind of guessing on the distance over here. I know it's off of this side. This is lighter, so we're going to crisscross this line. We're probably going to, by crisscrossing it, it keeps it from traveling this way, and we're probably going to have to be towards the stem there. But we're going to take a pick, and then we'll be able to balance this out. Okay. See, that's about middle there, and I just think we're going to have to be somewhere over here. Okay, that's a little too far over. Back towards the middle. That's pretty good. I'm not going to bother moving it. You know, it would be very slight. That's pretty close. All right, let's bring it up. Okay, let me get this dolly out of the way here. All right, and we can crank on our mill here. Lower our table down. All right, now we're going to be probably going up a little bit more. Okay, now with our gantry, we're able to go ahead and bring this right alongside our mill table here. Now, of course, we got to pitch our head, and we got to rest this down, and we got to clamp this down. How are we going to do that? All right, first off, we're going to plan out what we got for an angle. This is a 1/2 inch thick, and we want to feather a 1/2 inch. That's a 1/4 per side, and about 2 inches. So I'm going to be grabbing the protractor, and we're going to kind of take a look at that. How are we going to set it down so that it's flat and parallel? I have 2 giant parallel bars that I use in the hydraulic press, and I'm going to bolt those down to the table, and then we'll be able to block and clamp this thing down with some Bessie clamps, and that's kind of the plan. All right, so let me grab the protractor, and we're going to go ahead and figure out what that angle is going to be here first. All right, I took my bevel protractor and I kind of put the blade at an angle there. If I extrude it out and put it on the stop, either way, that's like 10 degrees, and it's a little bit too steep. It doesn't quite give us the drawn out angle we want. So what I did is I backed it slightly off. I brought it inside, and I just played with a travel of where it's at 2 inches from each other. In ballpark, okay? Just eyeballing it about 2 inches. I went like this, took 2 inches, start there, and come down here, and I've got about 250 thousandths in that 2 inches. And I come over to this side, and it says 7 degrees. Okay, so what I'm going to do is I'm going to go ahead and pivot that 7 degrees, and we're going to go ahead and figure that that cutter and that position will be where we want to work at the table, and we're going to work our table in and out with the leading edge and where we clamp to figure out where we're going to go with it. All right, so first off, I'm going to go ahead and pivot this to 7 degrees. I'm going to put the cutter in so that we don't have to lower it down more and then come back up to it, because I know that's what I would end up doing. We'll save that for when we're going to be maybe changing out an end mill, because we have these 2 ears on here, and while I was in there doing the plasma cutting, I didn't nip those off of there, but it wouldn't hurt to go ahead and put a roughing mill, turbo end mill, and buzz those off while we have it clamped down in the mill here. Okay, on this head here, I like using the 1/16" socket, and everything else I usually grab with this 1/16" wrench. Handles these and handles those locks and everything else, but this head comes in so close to the socket, and this lets you get in there and get some good cinch on it, so that you know that you're not gonna come loose. I mean, you don't want the tool pressure to be greater than the pressure holding your head, otherwise it's gonna take a hike. All right, let's see, we got to come over here, and we have degrees written right on here, and we're gonna be pitching it towards us. That was 8, and I think it's gonna be closer to 7. Now, when we get close and we get into the cutting nearly to width or nearly to depth, we will be able to see how close our educated guess of 7/1000 will be for that 2 inches. I know we could do it mathematically. I just quickly did it with the scale, sliding it, because we're just eyeballing it. This is not a required plus or minus few thousandths job. This is eyeball and put a fairing on the edge of a rudder for water contact only. All right, and about time for a new one of these dudes. Or grab some pliers and tighten them nuts. All right, and in reality too, if you took this is 2 inch here now, and we went ahead and put this in neutral and put a level here, we would have from this tooth, outside tooth, down to the top of the parallel surface of the table would be 1/4 inch. All right, now let's go ahead and get our parallels so we can get those mounted up here, and then we'll be able to slide those around. This rudder, we're not going to get this cut in one cut. This is going to be set it up and cut as much as we can, and then set it up and cut more. Whether we have to move it 3 times, I don't know. We have 28 inches, I believe, is the 28 inches to travel of my, 28 and a half or something like that. It's not, I just know that I absolutely can get 28. So, and also too, we were guessing earlier, but that is 36, and the top of it is 20. Well, the blade is 24. Outside to outside on this is 25. All right, let's go ahead and look at our 2 parallels. I have 2 of these. I've made them quite a few years back, and I have a series of holes that are through holes there, and then I have some tap holes, a couple smaller through holes, and I went ahead and I made them match sets. So these 2 here can be bolted to the table. Yeah, these 2 through holes are made to line up with the table. So I got to grab 14 nuts, studs, and nuts, and then we can position these anywhere we want, like that. And then this gives us the horizontal plane out farther from the table's edge. I use this K&T more for a horizontal milling machine or a horizontal boring machine than most anything. So and that was one of my favorite machines to run in the yards. So I adapt a lot to it. And when this head turns down sideways and everything else, it really does represent the horizontal boring machine. But I got this horizontal this way and this way here if I move the head. Alright, now with this head, you're offset from center of your table. So that's why you start limiting yourself on increments of cut, because of where you have to set up and where you have to hold it more so than where you're cutting. Alright, we already got that one on here. What I do is, and these are the short studs in the kit there, so it just happens to be that they fit perfectly, and the height and regular mill nuts work real nice with this as a setup here. And then by having another 1/2 inch out here, I'm actually able to pick up another thread if I want to, and another toe clamp right on top of this bar. But I think for our case here, we're probably, I got some weld splatter on there. I was using them in on the weld table there the other day. Alright, now we're going to be moving our table over. I think we're going to move it that way first, all the way, because we're going to be picking up on that lower edge there and then feeding it back this way here. We might even move this out to this outside edge so that we are at the farthest point here of the table. Okay. That's as far out as we can go. That's why we'll go ahead and we'll find 2 areas to set this on and then we will be cutting before the rudder starts, so we have room to start outside, because we're going to be milling in. When you got an angle like this, feeding in is not doing, because you feed straight across here, but then you start clogging the underside of your mill. You'll actually touch that center of that mill and start rubbing and creating friction before you start. You're not able to remove material once it goes past this outside, because of the positive rake to the tool. So everything's got to be fed in from the side. Bring the table up and feed into the side. Up, side. Okay, we're going to slide this on over and we're going to get a good look at about where it's going to be. Okay, we're going to figure out what we need underneath here for blocks, how far under here we're going to be able to go and clamp. We can't put any clamps over here because we're going to be we're going to be creating the cut here. And we may even have to bring this close so that we can be at the edge out here to actually do the clamping. I've already done that one there. But even though it doesn't really matter where these are at, I kind of like to square them to the table. Alright, I'm going to be using a square to set the part to the edge of the table. That'll be coming up here shortly. Alright, so both of these are locked down now. We can go ahead and bring our part back over here. These are 1-inch blocks. This is a substitute because I can't find a 4th out of the set that I actually have, and they're just basically 1-2 blocks. Alright, we'll be able to slide it from there. It's actually balancing, even though I don't know if we're going to carry some weight on it or not. We're gonna see how the table feels more than likely I will, and our travel's this way. Our hoist is in line, and that's kind of why I did it that way. So we will feel the weight and balance on this thing, and I'll show you how I do that. All right, we just shut it off for a minute because we're gonna be putting on, we're just putting a couple of these Bessie clamps. These are some pretty nice sized Bessie clamps, and they do the job when it comes time to hold something to take a little bit of material off. So I kind of like those. These are just lightly snug right now so that I can take my rawhide hammer and tap that leading edge square with the table. So let's head on over to the other side of the table with my rawhide. I'll need that. All right, and I got my square over there already. All right, so we set our square here, and we need it to go in. So we just hold the square above here, and then we can take this and tap it back till we can sight down the end of our, a little bit more. Okay, now here we got about 80 thousandths, just about touching there. Just down here at this end here, we got about 1/8 of an inch. Here we're touching. So there is a little bit of a curve coming in down here, but I'm going to leave that. I'm going to leave that alone. We're going to go by here because this is almost right there. When you come up and underneath it, just barely catches. I like that. Okay, let's cinch these down. Alright, now we're going to add some more clamps. Now we have this tapped hole here that we can go ahead and put a block out here and a toe clamp, and we can hold down right there. And we can have that clamp there, we can have that one, and we can add another one in on that bar there, as long as it doesn't interfere with our handles and stuff down below at the table level there. We don't want to be hitting a level, or a handle or a stop. And then I think we can crank this up, and we can start taking cuts there. We're gonna be easy in on this here. We'll see how well this cutter actually does on here, and then we're gonna kind of play around with whether we're gonna run flood coolant and do what we have to do to keep this fluid onto the table and in the sump. We'll kind of see what's going on, or we're just going to run it without any coolant. I'm going to go ahead and explain how I take the load off of here. Before I get fired up and going this way here, I want to make sure that I'm able to slide that way. So I have my brake off over here, and my brake's off here as well. I try to crank this thing in and out, and I can feel a really good resistance to the amount of resistance compared to when I'm free flowing with the table with nothing on it. I would be able to just glide this thing back and forth. So I know that the weight, because this isn't holding anything right here. So I go ahead and I crank up with giving myself a little bit of pressure on the handle, and then crank up slightly, and then all of a sudden this is able to go freely. All right. Now this tells me that I got the load equalized on here, and the table's going. I'm not overlifting, because then it would, if I went too far the other way, I would be binding again. And I can see I'm starting to bind right there. So I go ahead, let her down, and I'm loose again. Okay, now I can travel the mill this way here. And I'm just doing a run test here, making sure that all the travel and everything else is going to be good. Alright, I'm going to be able to go there. The travel's here. I'm not interfering here. Nothing underneath here is interfering. Alright, and I can still go in and out on the table, so that means that the gantry and everything else is kind of holding the same kind of pressure all the way for its travel. I'm happy with that. Alright, now I need to come up and I need to come out a little bit, because I want to adjust this. Now when I come out, I'm going to be moving the gantry, or the gantry is going to want to be pulling it in, and I want to go ahead and kind of align that too, and that's just going to be a vertical sight on the chain hanging down from here. All right, now I'm not going to have to come out too much because it looks like almost the width of the rule, so that's 1 inch basically that I've got to come out. And I'm just using this to kind of gauge. Yep, okay, that looks good. All right, I'm just kind of like letting it relax a little bit. All right, it kind of came out on that way itself. Chain looks pretty good. All right, do I still have the freedom? Yeah, a little bit of freedom in and out, no problem. All right, now I'm going to bring the table up, and I'm going to hand crank it and bring this up at the same time here. And what I do is I crank, but I just kind of like hold a certain amount of pressure on the chain fall, so it kind of creeps. And I'm just holding the basic same kind of load. All right, now we're going to be lower than this, and we got to cut this here first. So I'm going to go ahead and back this down and lower it down just a little bit, because we're going to start in on this piece here until we get this whittled down to where we'll be down to the plate there. Somewhere right around in there. Okay, we're free flowing in and out, so I know that I'm holding enough pressure here. All right, that feels pretty good. All right. And we're going to run our cut back, or our part back. All right, we're going to be underneath that. We're actually probably going to want to come out a little bit more to make sure we clear that. I kind of like that. I'm going to lock that down. Not yet. I got to adjust it as we come up. Okay, I'm happy with that. Okay, we're going to set this dial at 0 just because we want to know how much we're taking after this cut per pass. We're just kind of guessing on what we got there now. We're going to be seeing that, and we're going to lock the in and out at that point there. All right, RPMs, I don't know what we got yet. In fact, we got the wrong direction. All right, let's change the direction. There we go. This stainless steel, but that doesn't mean it's hard. It just means it's non-magnetic. It does have a little bit of properties in it that make it tough to super high speed, so we're not going to get crazy here, but I think that might be a little crazy. Yeah, we'll give that a shot. That's about 119 RPMs right there. Revolutions per minute. All right, I'm gonna move this by hand and see what we got. That sounds pretty solid. You know, that was probably every bit of 3/16 of an inch at the end there. That's not real bad. We do have the chips down there are slightly golden. I was clipping along pretty good by hand too as well, so I definitely know that was probably at least a couple inches a minute there. All right, I'm gonna set my other dial here so I can, when I rock it back and forth to get the right feel, I know where I'm at. I want to thank you again, Toby. This is another example where I can use the indicator holder you made me for the K&T, and while I'm cranking this thing in and out, I'm able to go ahead and come right back to my 0 mark. I'm cranking it in and out so that I know how easy the table is sliding on the ways, and that lets me know if the load is the bearing load on the part versus the ways is a good slide, so I don't overkill my ways on my machine. All right, so we want to crank it up, and we're going to go ahead and crank. We're going to crank 1/8 of an inch in here. Okay, and then we want to crank in and out, making sure that we've got free fly here. All right, and back to 0, lock down the table, and we're good to go for another cut. All right, I'm going to feed this one by hand again up to touching it there, and then I'm going to crank in some feed here. Okay, it's touching it. All right, now I got to roll some feed in here. That's about 1 3/8 inch per minute. Let's see what we got there. All right, I think, you know, that's doing it's raising some brown chips. Real light golden brown. Okay, we're going to go ahead and set it down to where we start getting down to where we're going to be making a really long cut, and then we're going to go ahead and start working about getting coolant in here. All right, we got coolant on it, and we just busted through. We just busted through this diameter here, and it looks like we're making a pretty good cut there. I'm going to back it out for a minute so we can look at our depth and our angle. There's our distance there. I gotta find my pocket scale here. Okay, that angle right there is about 1.5 inches. Okay, we're going to have to protrude down through here, and then we'll measure that height of that crest that we have by straight edge over and then down, and that will verify actually where we're at on our depth and our length overall will kind of play there. This just shows us that we're not going too deep. We should be able to flow. If it'll take it, let's take it. Here we go. Okay, that should be picking it up there. I'm at an inch a minute on the feed right here. Kind of adjusting the coolant. Now we're gonna have to contain this, so I might have to go get a piece of key stock to put across here and some monkey shit to like create the dam right there against the weld to keep that flowing over. If it flows over into here, we're good. We don't have to worry too much about where the coolant's going, because once it goes into the table, it feeds right back into the sump. Kind of the way the coolant works on the K&T. Alright, looks like we probably jacked this up back up to 1 3/8. We're going to shoot it there. The coolant just made those golden chips go away. The direction we're going, it is like climb milling. I'm going to pull it back towards me here. About 50 thousandths, because I think the leading edge, we want to be overhanging that. I can hear it like catching a chip, double cutting it. Alright, brought you over the back side here, and you can see I fed it out a couple of times because now we're over the edge. It was creating a wall, so it was rolling chips into that wall, and that's what the popping sound is. It seems to be pretty consistent now, so you need to have some place for that pressure to go. It's not, once in a while it does it, but it's not too bad. That's leaving a pretty good finish right there. It could be rolling underneath the bottom of it as well too. All right, let's move back a little bit here. Okay. Had a little something rubbing underneath there. Probably was on the other side. All right, let's bring you out a little bit here so we can see what we're actually up against here. Let's blow a little moisture out of here. All right, what we're doing now is we plunged in and we took about 1/8 of an inch from where we were. We don't know where that point was, but we can take this straight edge off of the surface and then drop down, and we are just under 200 thousandths. All right, and then we can measure, or this depth here, which we can take a set of feeler gauges and check underneath here, take a measurement of that and confirm that our angle is pretty close to what we had planned on this cut being. Right now we are about 1.5 inches, and we don't want to make, well, we can make a little bit of a line because we can ferret in with our with our sander, but we want to leave a little tiny flat on the end of here. It would be nice to, a 1/16 of an inch would be pretty good, just so it wouldn't wear or be knife sharp there. Alright, I grabbed my feeler gauges and I took a batch here. This is like 60, 61 if I squeeze it real hard there. And it is just starting to squeak by there. Okay, we'll pull out one of these and I can slip it underneath almost 1/8 of an inch. That's 52 thousandths. Okay, so I took out about a 10 there. It was an 8. I took out an 8 and it went in 1/8 of an inch. This just barely starts. So I'd say there's 60 thousand. I think I'm only going to take another 50 thousandths, and then will be the final depth for this cut up to here. Okay, this is coming to the end of the cut here, and just before we get to the other cut, I want to go ahead and lower. I'm going to lower the rudder away from the cutter. And then that way our cut is not going to be so sharp right into there. All right, I'm just going to lower it down. All right, now I'll stop it. Okay, that way there we didn't come in and make a sharp corner. All right, let's clean that up, back that off, and kind of look at this, because I believe this is going to be done here, and we're going to be ready to shift and move the rudder to its next spot. All right, I wanted to give you a little look here, and I think wipe this off. A little Scooby-Doo there. One of my new rags of the day. All right, you can't hate that. You can't hate that at all. This leading edge kind of shows you a little bit of difference. You'll see a little narrower there than down here. This is right on the verge of being right at the diameter, but it does have a little flat from that circle there. Very, very happy with this. All right, so what we got to do is we got to vacuum this up, lift it up, and move it over here. But I got some things that I want to do with my chain fall. I need to open up the cover and do some adjustment in there. It's not wanting to release the brake for the down, and I have to give it a little jerk, and I'm tired of jerking it. All right, it's all about the setup sometimes, where you can take something so big and put it on a smaller machine and do it maybe in a couple steps, but do it. This is one of those jobs where you think you might have a lot of chatter, a lot of fighting it, a lot of problems holding it, and taking forever. And this is actually clipping along pretty good. I'm pretty happy with this project. It is all in the setup, and you have some moves. It's not going to happen all in one day, but this project here is moving along really nice, and I like it. These bars they've worked out for me for I've done other rudders in here. That's why I knew that they were going to work, and I built them and planned them for this machine. But I took you through the steps, and I showed you why it works. And the heft, you got to keep the heft. This is a stout blade. This is half-inch blade. This is no squat to pea piece of material here. It is stout, and it holds. You can hear once in a while a chip will roll underneath the edge there, and you can hear it do a little crunch or whatever. And I'm surprised I haven't broke or dulled an insert yet on there. I haven't taken a real close look at it, but that shine and that cut, that shows you it's right there where you want it to be. Speed, feed, that's all kind of, that's, you know, I don't need to push it anymore. I don't need to go buy extra inserts just to prove a point. I can get through there, chug through there, and know that when I get done, I still have tooling to do something else. All right, until next time, get her done.